So let's go. So thank you, Adriana, and thank you to Stefan and to Dirk and also to Michel for inviting me here and allowing me to do this presentation. So when Stefan told me about this idea for an international coffee convention, he asked me if I would be willing to give a presentation, and I said, okay, but you give me the carte blanche on the subject. And I hope that, and Stefan told me, yes, it's a deal. So I hope he will not regret it. It's too late. Anyway. Those who know me are used to hear me about genetics, breeding, or coffee agronomy. However, for a long time, I have been thinking about sharing my experience and thoughts about the status of research and technical assistance in the coffee sector. And so thanks, Stefan, again, for giving me this opportunity. My presentation is on what I have observed, those 30 years of which I spent 20 years in coffee, living in coffee-producing countries. However, I feel it resonates with the challenges that will go with new coffee products, Cascara and others, and also starting research and technical assistance for new species, just like Coffea stenophila, and Liberica, for example. So, technical assistance and research is all about yield, yield, and yield. Excuse me, I got my prompter here, because usually on genetics I have I'm not using this, but here I think I need to. So, this is the holy grail. The absolute objective, the alpha and omega for judging the performance of a coffee farm and consequently of the farmers who manage the farm. Note that yield is expressed in kilograms of green coffee per hectare. There is no monetary unit in the expression of yield. Despite this, it is an accepted dogma that the higher the yield, the greater the benefit. Well, I'll come back to this later. Then, of course, there is a supposed optimal yield. This yield will often be obtained in research station or in a particular farm with an intensive and high input cropping system. In all cases, the ideal optimal yield is much higher than the one obtained by smallholders. So this is the famous yield gap. Yield gap is considered indisputable proof of the inefficiency of main smallholders, where 1.5 or 2 tons per hectare would be the bare minimum. Smallholders' average would be a disappointing 500 kilograms per hectare. And then the question is, why? Well, there are often 3 possible answers. Smallholders are ignorant, they don't know. Stupid, they don't want to understand, or lazy. Ignorant, this is the most flattering, in fact. They simply don't know. They don't know that fertilizer is good, that pruning is good, that weeding is good. Even though they're smallholders, they are the 4th generation of coffee growers, or the 15th if you are in Yemen. Even if those farmers supposedly unaware of the benefits of fertilizers on coffee trees are conscientiously applying the same fertilizers on annual crops and vegetables. But no, we think they are ignorant. So they have to be taught. And these are the famous training accompanied by the no less famous demo plots. But that's when we have to move on to stupid. Because even when the sustained efforts of training and demo plots, very often the yield gap is not reabsorbed. It's kind of annoying. Lazy, I've heard it. They don't want to make the effort. They expect the results without doing the effort. I swear, I heard it on several occasions. Right from the start of my career in agronomic coffee research, this trilogy, ignorant, stupid, lazy, was always present. And it certainly motivated and guided my career and research. When I say in my beginning, it was at the age of 22. With my degree in agricultural engineering, I was sent in Côte d'Ivoire. And I had 2 passions, genetics and soccer. I told you, Stefan, carte blanche. So And that's me in Côte d'Ivoire, in Ivory Coast. My point here is that I used to share soccer and after-game activities with the workers at the Divo Agricultural Research Center in Ivory Coast. I used to go to their homes with their families around the research station for a braised chicken or a glass of Bangui. I could see very clearly the difference between the agronomic and genetic trials at the research station and the reality of the village's plantations. There were two different worlds. The plots at the research stations were conformed to all the canons of the Green Revolution and the high input cropping system. The village plots were very low input, shaded, unpruned, and fertilizer free. And yet these families, these fathers and mothers, were not ignorant. Most of them worked as laborers in the big research stations. They had just next doors the biggest demo plot you could imagine. They didn't strike me as stupid, obviously, and even less as lazy. But how on earth could an agronomic result emanating from an ultra-standardized high-input Green Revolution research plot be transposed to such a different cropping system? Of course, there was a yield gap, but there was also a big gap. One of my commitments as a scientist is never to let myself get carried away by my opinions or my own experience, but on the contrary, to always support what I put forward with hard facts and bibliographical references. For this presentation, I said to myself, it's going to be difficult to find some bibliographical references that take up my statements and this trilogy about ignorant, stupid, and lazy. Of course, I moved away from purely agronomic references and delved into behavioral science literature. We don't have enough about coffee, and we certainly don't pay enough attention to what does exist on coffee. Well, as it happens, there are some very interesting references, and let's look at some few examples. And let's start with yield. JPAL. I don't know if you have heard of JPAL, but it is one of the most respected behavioral science institutes whose directors were awarded the Nobel Prize in Economics in 2019 for their work on poor people decision-making. Their department dedicated to the study of agricultural extensions published a report just a few days ago. I was lucky. And here's one of their key findings. The bold characters are mine. Extensionist recommendations may not sufficiently consider profit incentives for technology adoption, focusing instead on yield maximization based on experimental evidence from test plots that do not smoothly translate to real farm settings. This is pretty clear. One, too much focus on yield and not enough on profit. And two, practical recommendations, the famous good agricultural practices, are disconnected from farmers' real world. That was for yield. Now let's take a look at the yield gap concept. Let's listen to Alexis Aguilar Enriquez, who wrote in 1993 in his thesis work at the University of Montana on paternalism with poor farmers on part of agricultural development in Honduras. In general, one finds that development planners see poor farmers as backward and ignorant. They relate their relatively low yields serve as a proof of their backwardness to educated technicians. The outside experts assume that local information and knowledge are intrinsically inferior and therefore to be ignored. They thus feel they have nothing to learn from campesinos. Okay, now you're going to tell me, well, that was back in 1993 and that things have moved on. Well, not really. In a 2023 publication, very recent, Winholt and Gulao state, bold characters are mine, a regrettably frequent topic of conversation among rural development practitioners of all stripes is the headaches of implementation with program beneficiaries. Generally, compassionate implementers and researchers lament their struggles, tactfully implying farmers' stubbornness, short-sightedness, and opportunism when they do not truly buy into the latest agronomic technology or value-added upgrading strategy. Okay, so let's admit as a fact that coffee farmers are not ignorant, stupid, or lazy. Why then wouldn't they apply the good agricultural practices that would immediately double or triple their yields? Let me share with you a few examples. But first of all, if you ask farmers themselves what is their main problem, they won't necessarily tell you about yield. This is the work in Guatemala, in the Yepocapa zone, of a PhD student, Taya Brown, learning about the main constraints cited by coffee growers. Based on the survey of several hundred farmers, the main obstacles to production and sale of coffee were those that are listed here: low and variable coffee price, limited market access, high cost of coffee transport and field management, debt and lack of land title, access to processing and drying facilities, lack of education, natural factors like climate change, and theft of coffee. Where is yield here? The common recipe, and I can tell you without any doubt that an exterior expert who had to define a development project would have listed low yield, aging trees, need for training about renewing and good practices. The recipe would have again missed the point. I believe with many behavioral science researchers that if you consider the constraints indicated by growers on the left, you've already partly solved the problem, supposedly on the right. The problem, excuse me, let me go to that one. In this respect and related to it, I think that everyone would agree on the following cycle: high prices, low production, high prices, high production, and then again and again. But if we accept this scheme, we have to accept that coffee growers, they know how to adjust their production both downwards and upwards. So it means that the limitation is not really agronomic, but economic, mainly. Anyway, productivity or return on investment for the grower is often not the yield in kilogram per hectare, but rather the income per working day. Indeed, having neither money nor land in quantity, time, the working day, is the only possible investment for a farmer. So what is the return on investment for a working day on coffee? As a preamble, I should be pointed out that a small-scale coffee farmer is almost never just a coffee farmer. On average, surveys show that income from coffee accounts for 50% of the household's income. The rest is divided between on-farm, like food crops, and off-farm, often as agricultural workers on larger neighboring farms, or income even from a store in the next-door village. I had, fortunately, the opportunity to talk with many small-scale farmers. So just let me give you here a true example of the name of the farmer is Roger from the DR Congo side of the Lake Kivu. And he's got 1 hectare of coffee. He doesn't use any input and relies on shade and the organic residues of these banana trees interplanted with coffee to maintain his soil. He doesn't use pesticides either. So on average, he produces the equivalent of 300 kilograms of green coffee on his 1 hectare. From an agronomic point of view, Roger is a real loser with a dizzying yield gap. But we calculated with Roger the time he spent on this hectare of coffee, and we accounted 60 days for weeding and minimal shade tree maintenance. He has no harvesting days because he's selling his coffee on the trees, on average for an equivalent of 300 USD per hectare. As he spends nothing in cash, his income per working day in this field is around $5 US per day, or 150 USD per month, which is a substantial daily wage in his region. And what about the rest of the time? The rest of the time, he works as a day laborer or uses a small mop as a motorcycle cab. From an economic point of view, for coffee, Roger is very efficient, even if an agronomist would consider him as a loser. Here is another representative example from a rural economics studies carried out in Ethiopia by Professor Koshe, whose team from the University of Agro-Paris Tech. This work was in 2014. Studying different farms, they observed that among roughly similar small farms, those with a pair of oxen produced more coffee than those without. Oxen are useless for coffee, but are mainly used for plowing annual crops. Farms with oxen need less time for plowing, and they can sow and then harvest the maize earlier, and therefore have more availability for harvesting more coffee than farmers without oxen. So it would be more useful to have those farmers to acquire oxen than to explain them that fertilizer is good for coffee. Through this exploration of the science between decision-making mechanism, I discovered the incredible peer-reviewed work of Luc Boltanski and Laurent Thévenot on justifying a decision. It's of course a challenge to sum up in a few words, but the authors describe value systems that lead to decision-making. They describe 7 values systems, two of which are of particular interest for us, the industrial world and the domestic world. To put it simply, the industrial world sees scientific experiment as the ultimate taste supporting a decision. The industrial world is controlling the environment, is standardized, predictable, and replicable, and based on hard science. The domestic world sees the accumulation of long-term experience as the ultimate support for decision-making. The domestic world is essentially holistic, highly variable, poorly predictable. The main value is the local traditional know-how. But be cautious. These are not separate worlds. Each of us refers to one of these worlds depending on the situation. When I step into a plane, I expect the accuracy of equipment is based on absolutely standardized industrial criteria. But when I am walking in an unfamiliar forest and I hesitate to pick a mushroom, I will really rely on the local knowledge and the experience of elders before eating the mushroom. And just another what I wanted to add, just because on the EU regulation, you can see also that they really consider the tradition as support for decision-making for accepting a novel product. If it has been eaten or drunk for years and years in other countries, then they will accept without necessarily very hard fact, science-based evidence. Our agricultural experiments are all carried out using pure industrial world references in a hyper-controlled trials for which practices are ultra-standardized. This is the Green Revolution model. As long as farmers are in the same agricultural and economic condition, it's likely that they'll get the same results. But most small-scale farmers, they have nothing to do with those standardized conditions. They are highly variable, not only in relation to the research station, but also in relation to each other. What works has to pass the test of time in each situation, which, by the way, leads to resilient farming practices. So you may say only controlled experiment meets statistical criteria. Well, no. It's more complicated and fascinating than that. The industrial world studies the probability as an assertion being true in a given environment and with given conditions. This is known as the reductive approach in science. The domestic world studies the probability of an event over a set of possible conditions and a long time. It is more of the holistic approach. In other words, if in an industrial setting, I can say, I have less than 5% chance of being wrong when I say that fertilizer increases production by 20%. But I should add, under the conditions and over the direction of my experiment. In the domestic world, a farmer, for example, would like to hear there is less than a 5% probability that I will lose money by applying this dose of fertilizer in my situation and over a long period of time, several decades. And these observations are all the more important in the current context and paradigm of regenerative agriculture. I am not sure, really, that we realize the unprecedented change in interaction with growers. Since the Green Revolution and productivism, growers have been told, apply to the letter a set of standardized good farming practices, testing in our research stations, and you will optimize your yield. Admittedly, this was not overall conclusive, as we have seen. Now the message becomes, with the regenerative agriculture, do as you can in your specific conditions, but choose the methods that regenerate the soil, reduce the carbon footprint, and conserve biodiversity. This is quite a change. So between you and me, that's arguably what farmers were doing before the Green Revolution that began in the 60s and 80s. Anyway, technical assistance and mostly research strategy must adapt. People sometimes tell me paralysis by analysis. And I say no. I say no. All the contraries. For years, technical assistance has been paralyzed by a purely agronomic and productivist approach, which is of no benefit to many small growers. I therefore propose 3 ways of refreshing research and technical assistance. 3 points. 1, integrate behavioral sciences into the world of coffee. The talk of Madame Kirsten Kohler yesterday was fantastic on design thinking for that. Orient research project with institutes such as GPAD or any other research team in this field. Number 2, integrate into every development project a project design phase that identifies specific limitations and corresponding possible solutions. And I'm not talking about a mission of an agronomic expert lasting like a few days who will say, okay, pruning, fertilization, training, demo plots. No, I'm talking about a mission lasting a few weeks, combining agronomy and behavioral science researchers who will carry out in-depth survey with the growers concerned by the project. This survey will unveil truly adapted and innovative solutions. And number 3, initiate and generalize on-farm experiments. So what are on-farm experiments, or OFE? In fact, there is OFEs, they have their roots in the pioneers of regenerative agriculture, in fact, if you look at the very roots. I highly recommend this article by Myrtille Lacoste and colleagues. The main principles of OFE are preparing the objectives of the experiment with the participation of producers. In other words, ask the good questions to which the OFE should provide answers. Move away from research stations, multiply the number of in-situ farms, plots with a large number of growers to capture all the variability of growers, crop conditions, and environment in a given area. Evaluate profitability from the onset, not just yield. It is a responsibility of research to be able to tell growers not only the yield benefit, but also the labor and the cash cost that is associated with the given recommendation. Apply an holistic and multivariate statistical methods. In other words, modern big data approaches made possible by the computing power of our computers. Combine experiments and their results in a machine learning approach. Through this approach, producers' know-how is integrated. The variability of situation is integrated rather than the standardization. The answers are pragmatic and adapted to the reality. So here now my takeaway message. Small-scale producers are not ignorant, stupid, or lazy. it does not hurt to repeat it loudly. Regenerative agriculture corresponds to a de-standardization of agricultural practices. We need to call on and invite many more behavioral scientists to our conferences. We need to start working with on-farm experiment in coffee agronomic research. And I thank you for your attention.
Thank you very much, Dr. Montagnon. And now we come to the questions. Anybody like to?
Since we have growers here, or people coming from growing areas,
Okay.
huh? One native. Well, you don't know that he's from New Zealand, and I'm not telling you.
Thank you, Dr. Schwan. So it just crossed my mind. It's a very interesting presentation, thank you. And also behavioral science, I really never thought of that. But then again, because we work with small-scale smallholders in Sarawak, and then there's a very heavy cultural, contextual differences. So I'm just thinking, like, what are the implications when we bring in behavioral science research? What would be the first dimensions that you would actually suggest us to look into in terms of behavioral science of these farmers?
Okay. So the short answer is I don't know. In the sense that you need to be open-minded, and you need to not really presuppose what you will find out. So if, and there is always a specificity, wherever you go, wherever you travel in the coffee world, there are always specificities. So what the first step is actually to ask the question, to go and find out what about the tradition and the local culture and the local habits of growing maybe rice, or how does it compete or not with coffee growing, for example, in terms of calendar. And you need to find it and relate it to, and discuss with the farmers. So then, from the pick list of the whole menu of what can be done on coffee, try to find out with the farmers, what would be the limitations and what would be the constraints, and then plan your project based on that, not based on one message fits for all, as I was saying, fertilizer, pruning, Timor plot, blah, blah, blah.
Yes, thank you. Because just Sarawak alone has trust. Yeah. So
we have an example here.
Yeah.
This is how it works. It's 20 years working together with the farmers, earning their trust, accepting their cultures, having soccer together, marriage together, going to
marriage.
Yeah, we have it. We have it all. So
And-
just the example here.
And that's great, but see that it's not very common.
Yeah, sometimes just take Sarawak, for example, there are so many different tribes and regions, and then they all each have their own culture even. And it's not, the point you stress is very, like it resonates with us, because we do hear this stupid, ignorant, lazy stereotype all the time before we actually get in touch with these local farmers.
Exactly.
But then we actually take the effort to fly there and meet them and get someone to like really speak the language, we realize that's totally not the case. I am more lazy than they are.
They're always a mixture like everybody else. Go wherever
Yeah. So it's like in Kenny's presentation yesterday, like we just gave them the raw materials to build the greenhouse, and they built it within days, and even much better than we expected. Like if you give us the same materials, I would not be able to build it. So they are far from stupid, lazy, and ignorant, but we wouldn't know until we actually get in touch with them.
Yeah. If there is a good price, a good market, I swear they will, the next day they will find solutions. That's
yes, good prices also really resonate with us as well. Yeah. Thank you.
Yeah, thanks. Very inspiring. We know that we have no time to waste, right? And my question is, we have so much nice person here, nice approaches, but I'm always a little bit afraid that we go home after the conference and then we start bilateral projects. But how to bring all these important protagonists on one table to really decide what should become a secondary food, what should become a material, what should become energy, how to replace conventional fertilizers. So should we build a task force and start one perfect example that everyone can adopt, or how to bring the people together?
I think one very important point is on, I was talking about conferences in general, and actually Stefan here has brought many people, like the design thinking that we had yesterday was super interesting. I think even in ASIC, the very traditional scientific conference on coffee that was in Vietnam just 1 month ago, we don't have enough of social sciences. We don't have enough of outsiders from coffee that are not pure agronomic experts and that would bring a new angle to the table. And this, for me, this is the very first message, I think, in my takeaway message, that if I remember, that was the first one, like, let's bring some researchers that they've got PhD theses, just like geneticists, just like phytopathologists. They know their field of science. I mean, if someone comes to explain me what is breeding and genetics, I'll say, wait, I know a little bit. But now, if it is about social approach or how to deal with project with in Malaysia, like, I would say no. We have some people, they have learned a lot about it. They wrote papers, they wrote articles, they did PhDs. So those people should be part of the discussion, and there are not enough in the coffee sector. It is a purely agronomic in the ground. I mean, it is a purely agronomic expert world, and with a mindset about green revolution, productivity. Let's put fertilizer here. It will work over there. Just that, as they didn't know, those people, that fertilizer is good. I mean, of course they know.
Shall I? Thank you. First comment is thank you for your nice presentation, Christophe. Mm-hmm. Interesting, and I agree on most of what you have said. First comment is upon what you said is that often we forget that the first pillar for sustainability is economical, also for farmers. If you don't start from that, you go nowhere. That's very true. Yeah. My second comment is that often projects targeted in both interests, producing and consuming sides or exporting and importing sides, whatever you want, are lacking in output of the results. So when you go and check a project and say, what is the result of this project? Substantial result. You don't find it. You don't find it. It's amazing. Billions invested, and where is the result? Or millions of invested, where is the result? That made me mad a few times. And the third comment is, it's the multilateral and bilateral dialogue is fundamental to solve a lot of problems. But then you have to get up to the field, up to the small farmer, but never forgetting what is the need on the other hand side, because the problems are on both sides. So the producer, the farmer, but then who gets the coffee and has to put it in the cup for the consumer. So this is a very important dialogue you need, both for cooperation and development or for legislation implementation, but I don't want to anticipate too much of what I will be talking tomorrow. But I am perfectly in line what you have said, because and it's very interesting the behavioral sciences to be implemented, because I agree, the farmers are not stupid. At least not by default. You might find one, but not by default.
That's not the entry point. That's not the hypothesis. Thank you. Thank you for that.
Yeah, my comment would be about the conflicts of interest in the conventional research. If you look at all those papers, they say that farmers are stupid and you just use fertilizers. They are probably, if you look at the section, they are most often sponsored by industry who produces fertilizers. So we also have a problem to going against this, and they also finance much of the research. So we really have a problem here, and I currently look forward to the coming discussions how we will resolve this issue. Otherwise, I absolutely agree with you. This is the way forward, and I hope that you continue your good work and that we will have some going on in this direction in the future. Thank you.
Thank you, Dirk. Just one small comment, if I may, is that in fact it's not a lot of conflict of interest with input providers. It's more about the way projects are designed. And the real client of a project, in fact, is the donor, not the beneficiaries. So once you have a demo plot, and you can show that there were the small farmer plots here, producing 300 hectares per hectare, and then you put a demo plot here, totally artificial, but you put more fertilizer, you prune, and you show it is 2 tons per hectare. Then what you expect as an executing agency is maybe to convince the farmers, I don't know, but most likely, most importantly, to convince the donor that will come and visit your project and be astonished by the difference. And so, in fact, in the business model of this, the executing agency is here to show the donor that results are outstanding. So that's more the kind of, I would say, of bias in designing the projects.
Yes, maybe one comment also from my side. It's easy to tell farmers far away being stupid, but my personal experience in a big company is basically if you work between research and production, you have situations where you say, your synthesis is no good. I'm a good chemist, I will tell you how to do it and how to produce. I basically know your problem. But if you don't talk to the people producing, you don't understand the real problem. You say the costs are too high. Yeah, maybe it's just they have only 5 kilograms a year and they run a whole plant. So we've very much often had the situation that the lessons learned is you need to understand the problems of the people you're talking about, rather than to be ignorant and say, this is your problem. You need to do this or this or this. And the lessons learned, coming to the farmers, talking to the farmers, and living with the people together for a couple of days, and also going into the processing, doing some experiments tells you, okay, this is not possible. So somebody might come in and say, you do fermentation, I like you to have a constant temperature of 12 degrees. And you say, how would you do that? Does it anyway make sense? So you start with using the temperature profile, and you can adapt a little bit. If you don't do that, you tell somebody in India, do this, do this, do this, do this. Yes, sir, yes, sir. And then they ship it back and they say, what have they done? It's not to my idea. And it's really that in most of the cases, the people come with a predefined idea. What is the problem? What has to be done? And my experience is if you can really talk to the people, you have all the support, and if you really understand that the problem of the people might not be what you think it is. You might be a scientist that I need a scientific solution. And sometimes in a regulated industry, they just need to, let's say, calm down the quality guys. So they need somebody to write something. He said, am I stupid? This is so obvious. But they're so grateful that you solved the problem. And that is really, you need to build this relationship. And also we are quite ignorant, say, I'm a specialist in this. Ask somebody making chemistry and biology. So this is not completely separated. We have a lot of different techniques to look at this. The chemists have some very good ideas and to solve problems for things. And the biology people have fantastic ideas to solve things. And they don't match each other and have the same idea. So this is really, there's really a lot of attitude and things. You're in a family kind of situation and say, I'm a chemist, he's a biologist. You should come from the outside. It's the very best. Yeah.
Exactly.
So I'm a chemist going to the farm. It makes sense. Yeah. So
thank you very much for your input. We have to move on. Thank you. Yeah. So thank you for your talk.
Thank you.